this is a grade 9 plus targeted paper. It's towards more further maths GCSE students, not just regular maths. It's really for the astute among them. This is quite a hard paper, so you're not expected to get full marks. The entire point of this paper is that as you go through it and as maybe you see my solutions, you'll you'll find more interesting ways to solve some types of questions, and it'll help you to improve your intuition, hopefully. Some of the questions, actually, only one of them actually isn't on the spec. As far as GCSE further maths, for AQA, and yeah, and it's only a one marker, so the entire point why I even put that question in is because I find those types of questions really interesting, and I want people to maybe have a look into them in case they like them as well. Anyways, so yeah, Jamie throws a ball into the air, and it's modeled by this function, and then we want to find how long it takes the ball to reach its maximum height. Now, if you think about this, what actually is, like, how could you even do this? If you think about this, first of all, let's just rearrange for something. I've picked the height, okay? And the reason why I've done this is because if this is a quadratic here, and it's got an upside down parabola, because it's a minus something squared, so it looks like this. Now, if you imagine if you threw a ball, imagine it's following that path, right? It wouldn't actually be following that path in real life because of other influences, but just imagine it's following that path. Where does it reach the highest? Well, it reaches the highest at the turning point. And how do we find the turning point? It's by completing the square. Okay, and we don't actually want the maximum height, we only want the time taken to reach the maximum height. So let's just complete the square and we'll find what t equals and then what h equals, where t is the time and h is the height. Okay, so take out -1/8, so you have here -1/8 lots of t squared minus 3t, and then just leave the +9 at the end like that. And then just complete the square on this. So you have t minus 3 over 2 all squared minus 9 over 4. And here we can stop. We don't need to distribute this across this and then sum these two together, because that will only help us to find the height, and we don't care about the height. We only need to know that the time is 1.5 seconds, because it's the opposite of this number. The time is whatever number it takes, whatever number t takes to make this equal to 0. So the time is 3 over 2 or 1.5 seconds. Find the area of the triangle with vertices this. So if you just draw a simple diagram, you label this 4, 6 maybe, this one 1 minus 9, and this one minus 4, 3. One way that you can do this, there are actually a few ways to do this question. I mean, you could find the midpoint between these and find the height there and do half base times height. Or what you could do is you could just draw a rectangle around this, right? And the reason why I've done this is you'll see as I'm doing it. So the distance between here and here is 3, and then between here and here is 15, because -9 to 6 is 15. Okay, and then across here will be 8, because it's -4 to 4, so you have to go from -4 to 0 and then 0 to 4, so that's 8. And then here is 3, because it's 3 to 6, and then here it's 12, and then here it's 5. Okay, now if you think about this, if we do the area of this full shape, which is really simple because it's just a rectangle, and then we take away, well, it's actually a square, sorry. Oh no, sorry, it is a rectangle. I don't know why I said that. It's really simple to do this because it's a rectangle. You do the base multiplied by the height, so it's 5 plus 3, which is 8, and it's 8 multiplied by 15. 15 times 8, just do a quick you can quickly do that, I'm sure. It's 120. So the full area of this is 120. And the way to find this area here is we can take away the area of this right angle triangle here, and this one, and that one. Okay, so if we do this one first, we do half base times height, so we do 3 multiplied by 15, which is 45, and then half that, so it's 45 over 2 there. 8 times 3 is 24, 24 divided by 2 is 12, 12 times 5 is 60, 60 divided by 2 is 30. So you want to do the 120, this full area, take away this, this, and that. If we add these together, you'll get 45 over 2 plus 42. And then that's just, if this is 84 over 2. And then this here is 129 over 2. So you do the full area, take away this, this, and that, which is 129 over 2. So you do 120, take away that. This is 64.5. You don't even need to do that. You could just do it as a fraction. But then you do 120, take away that, which is 55.5 units squared. So that gives us this triangle area. the circle C has this equation, and it's been translated, so it's been moved 5 to the left and then 3 down. Okay, so if you imagine this has center 0, 0. You should just know that. And if you move the center 5 to the left and 5 down, the new center is going to be -5, -3. In the first page of this paper, there's this written in the advice section, and this will be useful because A and B are the centers, and so we can create a new equation for the circle, which is now circle B, using this. Okay, so we know that the center is -5, -3. Just plug it into there. We know what r squared is. It's 25. Okay, so we've gone from 0, 0 to -5, -3. Obviously, that's the new equation. I've just plugged it into there. Okay, and what we're going to do now is we want to find the equation of this tangent and this tangent here. Okay, they've got gradients of 2, which is what the question tells us. And now, one way that we can find them is by just this by itself. We can't do anything. But if we imagine a line that goes through this tangent here, where it touches the circle, through the center, and then through the other tangent, this is really useful because we know what this gradient is, which means we know what this gradient is. Okay, and if we know the gradient of this line and we know a point that goes through it, we can find the equation of it. And by doing that, we can solve this simultaneously with this equation of the circle. Okay, so we have this gradient of 2. That means this gradient is -1/2. It's negative reciprocal. Okay, and we have y equals -1/2 x plus c. And the points -5 and -3 are on it, so just plug in -5, -3. This is +5/2, that's -3. And then take away 2.5 from both sides to get -3/2 equals c. Plug that back into there to get that. Now, we've got this line here with this circle here. Now, whenever two lines intersect, you can solve them simultaneously because they'll have that same common x and y coordinate. That's what it actually means to solve simultaneous equations, is when you graph them. So we just need to substitute this into there and solve it simultaneously. So let me just get a new page because it's a lot of information. Just plug in this into here, right? So we'll do that. We've got this -1/2 x -3/2. So -3/2 plus 3 is -1/2. Sorry, no, it is 5/2. Sorry, I don't know why I said that. And then we're going to need to square this and square that. So this here will be, oh no, that's not what I've done first. I've simplified it first of all. So if you take out a half from this, it becomes a lot simpler because now it's just 5 minus x. Okay, and then this is obviously just a double bracket. You can just bring this out first at the front, and then you can work with the rest here. So you've got 5 minus x all squared, and then 5 minus x squared, that's you can just bring it together like this. And then up here, this will be 25 minus 10x plus x squared. And this here will be x squared plus 10x plus 25. I've already expanded that, yep. Okay, and then now you can just distribute and collect. So, oh no, that's not what I've done first. I've multiplied by 4 on both sides because it's a bit annoying to work with fractions here. So if you multiply by 4 and then you collect like terms, so you've got 5x squared plus 30x plus 125 equals 100. And then what I've done is divided by 5, and then I'll take away 25 on both sides. Oh no, sorry, take away 20 on both sides, obviously. And then just factorize this. So this is x plus 5, x plus 1. So x equals -5, x equals -1 are solutions. Now, we don't need to know whether it corresponds to this circle or that circle. You can kind of just work out. Obviously, this sketch is not accurate, as you can tell. But yeah, that's besides the point, because if this is -5, then it wouldn't be in the exact same spot on the x coordinate. But it's fine. So anyways, plug this into either this or the or this line here that we got last time, which is -1/2 x plus -3/2 or something like that. Anyways, just plug it into any one. You'll get this. And then just solve for y. So this is 25, and then y squared equals 0, so y equals 0 when x equals -5. And then plug in x equals -1, so you have -1 all squared. So you have y squared equals 24, so y equals √24, or 2√4. So those are the two coordinates. You'll have this and this for one of them, and then this and this for the other, right? And now we actually need to find the equations on them, not just the points. But it's fine now, because say this was -5 and 0, and then this is -1 and 2 root 4. We can just, well, we already know what the gradient is. It's 2 here and 2 here. So you can just plug it into y equals mx plus c. M equals 2. So y equals 2x plus c. Plug in -5 and 0 here, so you get 10 equals c. So y equals 2x plus 10 for this one here. And then same thing, but plug in -1 and 2 root 4. So you have this, and then add 2 to both sides to get that for c. And you can just leave it like that. And that's it. You know, I actually don't know why I didn't simplify that. Root 4 is obviously 2. So then 2 plus 2. So you have 2 times 2, which is 4. Then 4 plus 2 is 6. I have no idea why I did that, actually, now I'm thinking back onto it. I'm sure you wouldn't make a mistake like that. It was really dumb of me. It's fine, though. Anyways, fully simplify. You've got this here. One way that you can do this is if you realize this middle part here, this inside part, inside the radical, is just a perfect square. And that's just root a plus b all squared. And then this square cancels with that square, and you'll get a plus b. It's actually the absolute value, but it doesn't really matter right now. Anyway, so that's that was just a 1 marker, I think, was it? Yeah. Okay. Hence or otherwise simplify this. Now this is a lot more complicated, but we just have to kind of use our information from what we got from the first part here, and we said that this was equal to that, and we can just cancel the square roots, the square root and the square. Now I'm guessing, well, you should be guessing that you're gonna have to do a similar thing here. So we're gonna have to turn this into a square, and then cancel it with this first square root, and then turn the next thing into a square, and then cancel it with a larger square root. Okay, what I'm going to do is I'm going to focus just on this part here. So I'm going to ignore this larger square root just for the beginning, and then we'll consider it later on. So if we just take this inside part here, right, how could we write this as a perfect square? Well, if you think about this one here, it's a plus b all squared. This will be similar, but if you just think about it a little bit more, you'll realize that you're going to need a root something in there. So we could call that a plus b root c all squared, because you're going to need to get a term which has a radical in it. Okay, the only way to do that is if a has a root with it, or b has a root with it. It doesn't matter which one you pick, but you know, it'll be in this form, a plus b root c all squared. Okay, and this is helpful to us now because we could cancel this square root and that square root, and then we could just square both sides, to get that. Do not cancel those square roots. There's no point of doing that just yet. But yeah, so you get this, and then what I'm going to do is I'm going to square this side. So you have a squared plus 2ab root c plus b squared c, and then I'm going to compare coefficients. So what we're going to do is we're going to look at the radicals first of all. Radical is just like the square root. So we have 12 root 2 and then 2ab root c. So you can tell that this here and this here are somehow related. Okay, sorry for that. So this and that are somehow related. And they're related because if you just make them equal to each other, you'll be able to see that c must equal to, right? Because if these two are identical, they're the same, right? C must equal 2. And then if you divide by 12 root 2 on both sides, sorry, if you just divide by 2 on both sides and then divide by root 2 on both sides to get this, and then divide by 2 like I said to get 6 equals AB, we're going to use this just later on. But now that we've looked at the radicals, let's look at the rest of it. Okay, so we've got now we've just got 17 left, and the only thing that we've not looked at is a squared and b squared c. So 17 must equal a squared plus b squared c. Okay, and now we can solve this simultaneously where we have these two. Okay, we'll rearrange for either one. We could do 6 over b equals a, and then plug a into there to get this. This is 36 over b squared, and then just multiply by b squared on both sides to get this. Rearrange for the coefficient of b to the power of 4. No, sorry, I meant just get it in this form. Now, if you notice this is actually a hidden quadratic. If say you let t equal b squared, and then you just substitute it in, so you have 2t squared minus 17t plus 36 equals 0. You can factorize this into 2t minus 9t minus 4. You get this? So t equals 9 over 2 or t equals 4. Remember, t equals b squared, so b squared equals 9 over 2 or b squared equals 4. Square root both sides, so you get plus or minus 3 over root 2, and then plus or minus 2 for that one. Rationalize this, so this is 3 root 2 over 2. And this here, we'll just leave this for now. We'll have a look at this one. So b equals plus or minus root 2. If we plug in positive 2 for b here, a equals 3. And if we plug in negative 2 for b, a equals minus 3. So a equals plus or minus 3, where the solutions are kind of like complementary. So positive goes with the positive. So positive 2 goes with positive b. Sorry, positive 2 goes with positive 3. And then minus b goes with minus a. And it'll be the same thing here. I'll just substitute it in so you can see it. But if we go with the positive solution first, multiply by 2, divide by 3 root 2, you'll get a equals 4 over root 2, or just 2 root 2. And then if you plug in the negative solution, you'll get the same thing, but just, the negative version of it. So it actually equals plus or minus 2 root 2. You can just plug in minus 3 root 2 over 2 into there to find out what it is. It'll be minus 2 root 2. Obviously, the positive goes with the positive and the negative goes with the negative. And now we've got what a equals and what b equals. And remember, we had this originally. Now, you're probably wondering, well, we've got 4 solutions right now, so which ones do we use? Well, it doesn't actually matter as long as you're consistent with them being complementary. And what I mean by that is you can't pick positive 3 and then minus 2. Because remember, the solution for when a equals positive 3 was b equals positive 2. So just, pick the correct solutions. By right solutions, I mean like the positive a goes with the positive b, or the positive b goes with the positive a, or negative a goes with negative b, and negative b goes with negative a. That's what I mean. Either one will just give you the exact same answer. I'm just going to pick positive 3 and then 2, because they're just simple numbers. You could pick these two if you wanted to. You could even pick the negative versions of them. Makes no difference whatsoever. I'll just pick a equals 3, b equals 2. So I just plug them in to get this, and then I'll plug it back into here, because you remember this here equals this. So if I plug it into there, this cancels with that to get this, and now we just need to do everything just one more time. I know it's long. There is a much quicker way to do all of this, but the only reason why I'm showing you this way is because it's more intuitive. So I think it's more important to understand this way first, and then you can learn the quicker way maybe in your own time. So yeah, we'll say this, we'll square both sides to cancel that, expand this, be almost the exact same as the other one, look at the radicals, e equals 2, here, then you've got this, cancel the root 2's, I divided by 2 here on both sides to get 1 equals cd, and then you've also got this, it's the remaining 3 equals c squared plus d squared e, rearrange for either c or d and then plug it into the other one. You'll get this, multiply by d squared on both sides, you'll get this, and then just, this is another hidden quadratic, just say like let k equal d squared, plug into there, you'll get this, but we're just 2k squared minus 3k plus 1. You'll factorize it to get this, so 2k equals 1, so k equals a half or k equals 1. Plug in, replace k with d squared to get this and that, and then d equals 1. So you've got this and that. This is actually 1 over root 2, but you can just rationalize it to root 2 over 2. It's the same thing. Now we've got c, we've got d, and we've also got e. Yeah, you can just plug it back into there, cancel that with that, to get a final answer of 1 plus root 2. An island has 3 sections to it. 20% of the inhabitants live in section A, several 13ths live in section B, and 427 live in section C. How many inhabitants are there altogether? Now, if we say that the total number is actually just x, okay, then we can write everything here in terms of x, except for this one, obviously. So we can say that 20 over 100 x, or 1/5 x, live in A, and then we don't know what this several is, so we'll just call it y. So we have y13 x in B, and then we have 427 in C. Now, if you sum all of these together, that will equal the total number of people, which we've just said is x, and then we'll rearrange for x to find what it is. Few ways that you can do this going from here. What I did was I added 427, sorry, take away 427 from both sides, and then take away x from both sides to get this, factor out the x to get that, and then I've divided this, and then I've divided it by this to get that. And then what I'm going to do is I'm going to make the denominators of the denominators all the same, so you can put them under the same one. You know, this multiplies by 13, this multiplies by 65, and then this multiplies by 5 over 5. You'll get this. Just collect these together. Yeah, so you've got 13 plus 5y minus 65 all over 65. When you have a complex fraction like this, where you've got a fraction inside of a fraction, you can just take this denominator here and multiply it out by this one. I'm not going to actually multiply it, I'll just leave it like this, and I'll show you why later. I won't explain just now, but you might see where I'm going with this right now. Anyway, so you've got minus 65 plus 13, that's minus 52. So you've got this. And then, now that we've got this, we need to do one thing. And I'll say what that is just in just a second. We know that y is less than 13. You might have seen that I wrote that last time. But the reason why it's less than 13 is because if it was 13, then that means x people live in B. But we can't have the total number of people living in B if we already know that there's a constant amount of them living in C, if that makes sense. So, you know, the number of people living in B is less than 100% of the total people. Hopefully that makes sense. Now, y is not going to be negative. It's going to be a positive number. Now, because it's a positive number, the problem is the problem here is that this could be a negative number for x. Now, we don't know what x equals, we don't know what y equals yet, but we can deduce it because we know that x, the total number of people, has to be a positive number, right? You can't have a negative number of people living somewhere, and you can't have a fraction number of people or decimal number of people living somewhere. So what I'm going to do is I'm going to multiply both sides, the top and bottom, by -1. Okay, and this is useful because it makes the risk of us accidentally getting a negative number less. The reason why that is because now here we can clearly see that y has to be less than or equal to 10. Because if you had y equals 11, then you'll have a -3 at the bottom, and then this x will be minus. It'll just be minus. If you had y equals 10 though, then you have a 2 on the bottom, and then this will stay positive. So that's useful to know. We said that originally it was going to be less than 13, but now we're saying it's less than or equal to 10. Alright, so let's just try values. But we're not going to do that just yet. What I'm going to do is I'm going to factorize this top even more. We know that 65 is 13 times by 5 because we did that last time when we was putting them over the same common denominator. And 427, this might take you some time, to be honest. This is one of the things that I don't like about this question that I wrote, is because, you know, it might not be immediately clear what this factorizes into, but hopefully if you know your divisibility rules, it might come to you pretty quick. If you use your divisibility rules for 7, where you split the number into the last number and then the first part of it, you double the last number to get 14, and if 42 is divisible by 14, then this number is divisible by 7, and then you can just do a quick bus stop to find out that its factor is 61 multiplied by 7. So you've got this, and here you'll notice that 61 is actually a prime number. I'm hoping you'll notice that. You can just try a few numbers maybe if you don't see that straight away, but 61 is a prime number. And now we have to deduce, well, what can y be? Let's picture if y was 1. Okay, the reason why I did all this, actually, let me just explain it now, is so that whatever denominator we get, we'll be able to immediately see if it cancels out with this. Because if it doesn't cancel out with these prime factors, okay, then the problem is we'll 100% have a fraction for x, and we don't want a fraction because it's they're people, they're going to be whole numbers. So we need this bottom number here to cancel out with either 61, 7, 13, or 5. Okay, so let's just try it. Well, if we plug in 1, it won't cancel out because 52 take away 5, it'll be 47. 47 doesn't cancel out with any of these. The reason why we factorized it is just because it's so much more clearer to say, is 47 one of these numbers? No, so it's not 1. y is not 1. Try 2, you'll have 42. Is 42 one of those numbers? No. Let's try 3. So 5 times 3 is 15. 52, take away that. But anyways, yeah, you just try it up to see if this number is any of these. You'll go up to 7 and then 8, and then if you try 9, I'm sure 9 would be the next one that you check after deducing that y is less than or equal to 10, because it's right next to it. But if you plug in y equals 9, you'll get 9 times 5, which is 45, and then 45, and then 52 take away 45 will actually be 7. Is 7 one of these numbers? Yes, it's that one, so it cancels with it. Okay, so y must be 9. So you'll get this, and then you'll get 7 on the bottom. Is 7 one of these numbers? Yes, so this cancels with that. You'll have this, just, we know that this is 65. 65 times 61. Just, you can do a quick table and find out that this is 3965. Okay, y, the only value for y is 9. You can try other ones. All of the other ones will give you fractions. Next question. So we've got this here, and it's telling us that sine squared theta plus cosine squared theta is identical to 1. You should know this because this paper is targeted towards some further math students. So yeah, you should, to be honest, you should know this. Anyways, yeah, so we'll just solve for theta here. We want it between 0 and 360 degrees. Okay, so one of the best things to do is, well, what we can do is, I'm just going to multiply by cosine theta plus 1 and then sine theta plus 1 on both sides. And then if I did that, this would be sine theta multiplied by sine theta plus 1. And then this would be cosine theta multiplied by cosine theta plus 1. And then this would just be sine theta plus 1 multiplied by cosine theta plus 1. You'll get this. You could just put them over the same denominator and then multiply it out. You'll get the exact same thing. It doesn't matter. Distribute this and then distribute that. Just leave this for now. Sine squared theta here, cosine squared theta here. That equals 1 because it tells us up here. So you've got 1. The rest of this. And then here, you can just expand this. And if you expand it, you'll notice that you'll have sine squared theta and then cosine squared theta here. Actually, no, sorry. No, you wouldn't have that. I don't know why I said that. You'll have sine theta, cosine theta, and then you'll have plus sine theta, and then plus cosine theta, and then plus 1. The one there, the one from here, and then the one from there cancel. So you'll have a 0. And then you have the sine theta, and then cosine theta. Sine theta plus cosine theta, which will cancel with this and that. So you've just got 0 on this side, and then you'll just have as a remainder sine theta, cosine theta. You could just expand this and then just notice that you might just be able to do this a bit quicker. But anyways, you will get this eventually. So this tells us that either sine theta has to be 0 or cosine theta has to be 0. Let's consider when sine theta equals 0 first, and then cosine theta equals 0 later. For when sine theta equals 0, well, the solutions between 0 and 360 degrees are, first of all, you've got 0, and then 180, and then 360 degrees. You can notice that just by looking at the graph. If you can imagine it in your head, you've got 0 here, and then 180, and then 360 once it completes the full loop. For cosine theta, you'll have 90 degrees and then 270 degrees. This is because, say if you have 90 degrees as the first solution, the next one will be 360 minus 90 because of the periodicity, the periodic nature of the curves. Okay, so you'll get 90 degrees, 270 degrees. I'm sure you'll be able to do this. I mean, this isn't too difficult. If you notice just one thing here, we're saying that theta can equal this, and this. But maybe theta here cannot equal theta here. Because let's just plug in some values. You might be able to notice that if you imagine say sine of 270 degrees. So if we plug in 270 degrees into just say, let's say this fraction, for example, sine of 270 degrees is actually minus 1. So you'll have minus 1 plus 1, and then you'll have to divide by 0, but you can't do that. So what you actually need to do is you need to discount this solution. You can check all the others, they all work. 270 degrees is the only one that doesn't work. So the only solution you've got left are this, and that. Circle C has this equation, circle D has this equation. Given that root 2 is greater than 1.4, show that circle C lies completely within circle D. Give your answer as an inequality. Okay, you can just sketch these circles. Remember, there's advice at the front page to explain this to you if you don't know it. But just roughly, you should be able to see that you've got one circle that's bigger and then a circle that's smaller. We're told that it's within it, we just want to prove it. So it should look something like this. Okay, now one way that we can show this is, if you think about it, the furthest distance from this smaller circle to the center of D should be less than the radius of D. So between this blue dot and then the red circle there. I hope that makes sense. Maybe just think about this. Maybe just pause the video and think about this for a couple minutes. Hopefully that makes sense. For any circle, if the distance between the smallest circle and the center of the other circle is less than the radius of the larger circle, then it lies within it. Okay? You know, if you sketch this, it becomes much easier to see. But anyways, you know, this is the case. So what is the radius of D? Well, it's, you know, root 50, and then the radius of this one is 5. Okay, so if we imagine this and then to here, so that's just the distance, the furthest distance from this black circle to this blue dot here. So that'll be 7, because you've got this distance of 2 here plus this distance of 5. Okay, and then the radius of this here will be root 50, so that's from here to that red circle there. So that's root 50 or 5 root 2. Same thing. We have to show that 5 root 2 is greater than 7. Okay, how can we do that? Well, we're told that root 2 is greater than 1.4. Let's just say it's 1.5. It's not 1.5, but let's just say so. Okay, if it's 1.5, it's 3 over 2. So just plug in 3 over 2 into there to get this. This is 15 over 2, which is 7.5. 7.5 is clearly greater than 7. So, you know, hopefully that's conclusive enough. You could just actually use this inequality normally to get the answer, but you know, even if you use like 1.40001, you'll get the exact same answer. You wouldn't, not the same number, but you know, you'd get the same answer. Anyways, that's it. Next question. So we've got this sequence here, and we want to show that there'll be no more integers other than the first one, obviously. If we write this as 3 over 1 like this, hopefully you can see that there's actually an nth term to the numerator and then an nth term to the denominator, because look, it goes up by 2 each time, right? And then this bottom one goes up by 1 each time. So if we find the nth term of the numerator, which will be 2n plus 1, I'm sure you can do that, and then the bottom one will just be n. Okay, you'll have this, and we need to show that this will never have another integer. One way that we can do this is, actually, if you're doing further maths, one way that you might think of it is, you know, if, oh no, sorry, never mind, yeah. So we'll just carry on with what I was going to say. So we'll have, if we split this up to get 2n over n and then plus 1 over n, okay, this tells you that, well, you can just cancel this and that, so this is just 2, obviously. You have 2 plus 1 over n. Now just think about this. 1 over n will never be an integer except for when n equals 1. And when n equals 1 is just 3. Okay? Yeah. So when n equals 1, it's just 3. So, you know, this will never have an integer except for when n equals 1. So, that's enough for the answer. You do need to give that statement, by the way. This question is just completely not on the spec, but I just find it interesting, and so hopefully you may too. Anyways, you've got some information here. We're told that an inflection point is a point of rotational symmetry of 180 degrees. All inflection points meet a condition A, where there are points which are not points of inflection that meet condition A too. Now, you don't actually need to know what condition A is. You don't even need to know this beginning point here. This is kind of just maybe to throw you off or confuse you. But if you're curious what condition A is, it's whether the second derivative is equal to 0. Because even if the second derivative is equal to 0, it doesn't mean that the point is an inflection point, because you have to check around it. But anyways, so we're told that all must meet condition A, but there are some, sorry, all points meet condition A, but there are points which are not points of inflection that meet condition A too. Okay, so if it's an inflection point, it meets condition A. Okay, but if it's actually no, let me phrase it like this. If it's the condition, then it's not 100% an inflection point. I mean, just kind of think about it. If A, then it's not always an inflection point. But if it's an inflection point, it's always A. And so this hopefully might help you to see that it's necessary that an inflection point is A, but it's not sufficient, because you could have another point that's not an inflection point that's A. So it's necessary to say that all inflection points meet condition A, but it's insufficient to say that just because it meets condition A means that it's an inflection point, because that's not always necessarily true. So it's not necessarily true. Sorry, it's not always necessarily true, but it's necessary, but insufficient. Hopefully this makes sense. It's quite confusing with like the way it's styled. If you're interested, like TMUA specifically will have lots of questions like this. If you search up necessity and sufficiency, they'll have you know, better tutorials and better guides and more questions and better questions even that will help you to understand this topic more. You know, it's really important if you want to apply to maybe some you know, very prestigious universities like Oxford or Cambridge. You might have to answer lots of questions like this on necessity and sufficiency. But yeah. But yeah, you might have to answer questions like this. Anyways, I hope that was a sufficient explanation. Anyways, question 10. There's this curve here, and it's got this root here and this repeated root, okay? And we've got this y-intercept. You don't actually need to know this. Anyways, we're told that actually, I guess it's a bit helpful. Anyways, so how could we find an equation for this? Well, if you think about it, if you have a quadratic and you'd factorized it, if you have, say, x minus 4 all in a bracket, and then you have x minus 3 all in a bracket, you know that the roots are 3 and 4. So it's kind of just like doing this but backwards, and hopefully you can see that this is just going to be x plus 1 in a bracket, because when x plus 1 equals 0, x equals minus 1. So you've got x plus 1 here, and then you've got x minus 2 all in a bracket, because obviously x minus 2, when that equals 0, x will equal 2. But you've got that twice because it's a repeated root. And we know it's a cubic, because if you've got this one here, and it's going to be to the power of 3, you've only got 2 more roots, which will be here and here. So you've got 2 roots here, 1 root there. Anyways, you'll get this. This, just expand it. This, if you expand these two, you get x squared minus x minus 2. And then if you expand this and that, you'll get x cubed minus 3x squared plus 4 equals 0. And that's it, that's the answer. The circle A has this equation, the circle B has this equation. Both circles intersect at 2 points. Find the equation of the line passing through those 2 points. Okay, so both circles intersect. Well, if they intersect, that means you can solve them simultaneously. But maybe that's not the best thing to do. Because if you think about it, this is just going to be really, really complicated to solve. Because imagine rearranging this for x, and then, you know, plugging it in for x, and then plugging it into there, and you'll have fractions and you'll have radicals everywhere, and it'll just be annoying. So one thing that what I'm going to do is I'm going to write this like that, and then I'm going to expand this to get x squared minus 20x plus 100. Okay, and then I'm also going to expand this to get y squared minus 22y plus 121 to get that. And then collect, you know, this, so that's 221, and then minus it from 100, so you'll have minus 121. Okay, I'm gonna put these squares together to get that, and maybe this is just a bit easier to solve for you. You can see that x squared plus y squared is just 49, so you could actually just plug this into there, and you'll notice, well, we want a line. We've got y and we've got x. Okay, well that's how a line is like. You've got a y in it and you've got an x, and then the other thing will just be the y-intercept. So you could just plug in x squared plus y squared equals 49 for this here. Now, I've only just noticed that now, but that's not the way I've done it. What I've done is I've written this here as x squared plus y squared plus 0x plus 0y equals 49. I've written it like this. Okay, the reason why I've put this 0x and this 0y here is because you can just solve this simultaneously. So, you know, which we've already just done when I've just spoken that aloud. You can subtract this from that. So here you'll have this x squared and that x squared will cancel, y squareds will cancel. You'll have minus 20x minus 0, so that's just minus 20x. This all stays minus 22y. So you have minus 121. Sorry for that. So you'll have this take away that you'll have, yeah, so that's going to be what, minus 170. For some reason I've written this out twice. Oh no, never mind, I've just added 20x to both sides, and then divide by minus 22 on both sides to get this. And you can just simplify this, obviously. And this is the equation of the circle. Sorry, not of the circle, of the line. I don't know why I said circle. You could just do what I said last. Yeah, so you could just do that. Anyways, you know, hopefully you can see that the only thing that you need to get rid of is the squares to get, you know, a linear equation, which will just be the line that passes through those points. Line segment ABC is split such that AB to BC is 4 to 5. You've got these coordinates here. Just draw a sketch. So you've got this line here, you've got 3, 7 here, and you've got 9, 12 there, and you've got some random B, which we'll just call has coordinates x, y. The distance from here to here, the x coordinate, will be 6, and then this here will be 5. So that's 6, that's 5. It's split up so that there's 9 parts between from A to C, because if A to B is 4 and then B to C is 5, then A to C is going to be 9 parts. So if we say that there's 9 parts going horizontally, we know that equals 6. So 6 equals 9 parts. So 1 part is just 2 over 3. We don't actually want 1 part. We want 4 parts because we want to go from A to B. You could go from C to B and actually do 5 parts and go backwards. But I'm just going to look for, I'm just going to get 4 parts. So I'm going to multiply this by 4 on both sides to get 8 over 3 equals 4p. Okay, so we know that we need to move a distance of 8 over 3 horizontally to the right to get to B. Okay, so we have got this coordinate here, 3, and then we're going to need to move to the right. So by 8 over 3. So we're doing 3 plus 8 over 3. This is going to be 17 over 3. I'm sure you can do that. Now we can say that equals our x value here. So that equals x. And then we'll do the same thing for this one. So this is also 9 parts. We'll call it some other variable, not p, because we've used it there. So we know that it's going to be 9 parts, you know, from here to here. So 5 equals 9k. K equals 5 over 9. And then we want to multiply that by 4 because we only want to go 4 parts across, not that full 9. 4 parts above, sorry. Up. So multiply that by 4 to get 20 over 9 equals 4k. And then you'll need to do 7, which is well the starting y coordinate, add 20 over 9. And then that will give you 83 over 9. This is obviously going to be 63 over 9. 63 plus 20 is 83 over 9. So that y coordinate is equal to 83 over 9. So you got 17 over 3, 83 over 9 for the coordinates of B. Next question. This question is probably my favourite on the entire paper. Anyways, okay, so I'm going to skip past all of this waffle. What you need to know is we've got this satellite, and it's moving down, up in this and it's following like a trigonometric function. Okay, and it goes down by 100 and then up by 100. Okay, what you should be thinking right now is, how do I even get started? You could use a sine graph. You could say, well, if you imagine a sine graph, it could start here at 0. But then the problem with that is the sine graph then goes up. So you're going over the over this boundary, and we know that it has to stay within this boundary. So if it starts up high, then you're going to need to use a cosine graph. Okay, you could use a sine graph and just manipulate it a little bit, but it's just much simpler just to use a cosine graph, because you know, you can see here that it starts high and then it gets down and it'll reach the midpoint, which is here, around here, and then it'll go down to this minimum point here and then go back up to here, but over there. All right, and it's going to need to go this cosine graph goes from 1 to -1, but the problem is we actually need this to go we basically need it to cover a distance of 100 completely. So one way that we can do that is if it goes from 50 to -50, because from here is 50, distance of 50, and then here's another distance of 50. Okay, so if we can somehow get this to go 50 here and then 50 there, that'd be much more helpful. So if we say that this is 50 and then this is minus 50, the way that you can write this is just y equals 50 cosine x. I'm sure you know this because of your this is in the curriculum. I don't know if stretches and squeezes are actually in regular GCSE or even in AQA further maths, but I'm sure while revising for this you might have come across this. What this means is we're just multiplying the y coordinate by 50. So this is 1 times 50, and then this is minus 1 times 50. Okay, so that's this new graph that we've created. Okay, now let's see, is this enough for us? We're going to work with the rest of this information a bit later. Same with this, just a little bit later. The cosine graph, well, it repeats every 360 degrees. So this here ends at 360 degrees. Now, that's not very useful for us because we want it to go down and then go up every 3 minutes. Because if it takes 1.5 minutes to go from the top to the bottom, it'll take 3 minutes for it to go from the top to the bottom and then back up. Right, so we need this here to be 3, not 360. Okay, so and we want to keep this from 50 to minus 50 the exact same because we need that, and we need this to be 3. Well, how do we do that? Well, we can squeeze it by 360, okay, and then we can multiply it back out by 3, because if we squeeze it by 360 it'll repeat every 1, but we want it to repeat every 3, so then we'll multiply that by 3. And now when you're doing that, you actually do the opposite, because if you remember, instead of dividing by 360 and then multiplying by 3, you'll do multiplying by 360 and then dividing by 3, because if you think about it, inside the brackets next to the x, you do the opposite. So you're actually doing this. This is obviously 100. Sorry for that. This is obviously 120x. So you've got this. Okay, and now how does this help us? Like, what can we do with this piece of information? If we think, okay, well, the x, we're imagining the x like coordinate as being the time, because we're repeating every 3 minutes, so this here, it goes across in minutes. Okay, and we want where it goes, what the y value is after 2 hours and 34 minutes. Now 2 hours and 34 minutes, that's just going to be 154 minutes, because 60 times by 2 is 120, 120 add 34 is 154 minutes. Okay, and we're saying, okay, well, we're going to need to plug in this into there. Now if you plug in 154 for x into there, that's just going to be a massive number, and just good luck trying to solve that. You could do it, it'll take a little bit more time, but we can be a bit smarter about this. Well, we know this graph repeats every 3. Okay, so if we do 154 divided by 3, okay, and if you write that as a mixed number, you'll get 54, 51, and then 1/3. I don't think this will be too hard to actually do, I'm not going to lie. You can see that 50 will get you to 150, and then 51 will get you to 153, so then you've got 1 left over. Okay, so you've got this. So before it gets to 154, it does 51 complete cycles, and then it does a 1/3 cycle. So it's 1/3 of this full cycle of 3. So it's 1/3 of 3, so it's 1. Okay, so after doing 51 cycles, it does an extra 1/3, so it goes across 1. So where it is after 154 minutes is the exact same as where it is after 1 minute. And that's just much easier, because if you imagine it, if you go across 1 minute here, that gets us to here. 154 minutes will have the exact same y value, but just somewhere like really far into the x direction, positive x direction. So we can say that x equals 1, because that's the same as when x equals 154. And we can plug this into there to get 50 cosine of 120. Cosine of 120, you can use the regular cosine x graph to find out that equals minus a half. So you've got 50 multiplied by minus a half, which is minus 25. So this gets us down to minus 25 meters. Now, minus 25 meters is definitely not the answer, because if you think about you can just use common sense. You're not going to be in the ground after being 402 kilometers up from away from the surface of the earth, are you? So why is this the case? Well, this goes only from 100, you know, it only spans across 100 meters, but we want it to span 402.3 kilometers. Now, you could have made the graph such that it goes half of that distance up and then half of that distance down, and then just gotten the exact y value. But if we imagine this, so the distance from here all the way to the ground is 402.3 kilometers. That's 402,300 meters. Okay, because we're working in meters, right? Okay, and now we're saying, say let's just imagine a different like solution. Imagine we got that y equals 25. Okay, how would we find the distance from here all the way to the surface of the Earth? Well, if this larger number is 402,300, and then this number here was 25, imagine we got y equals 25 there. Okay, then this distance here would be 402,300 take away 25 to get this. Sorry, not get that. To get you know, to get from here all the way down. Okay, so what we can do is we can get from here to here and then here to here. This is 25 plus the difference between this and that. Okay, I'm hoping you can see that. Or another way to think about it actually is, if this is 402,300, right, and you take away 50 from it, you'll get this. Okay, and then now you've got this, you've got the midpoint here. Now you can just go up whatever that y value was. You've got now the middle here, which is 402,250. So you've gone from here to here, and then you need to go up the extra y value that you calculated, whatever that value is. Now, our number is actually down here. So how do we use that, but in our case? So obviously, we're going to do the exact same thing. We're going to go from here to the middle here. Now, how do we go from here and then down there? Okay, well, we know what this is. You know, and then we also know what this small distance is here. This small distance is minus 25. It's actually positive 25 if you think of it as a distance, but the y value is minus 25. Okay, and this here is going to be 402,250 because it's just this massive thing take away this 50 here. Okay, so how do we get from, sorry about that again. Anyways, what I was saying is, so how do we get from here to here? Well, we can do this big distance here, take away this one. Now, we don't actually need to do a takeaway in our case, because if you add, because this is already a negative, but if this is a distance, it's going to be positive 25, so we can do this. I need my charger. Sorry for that, my sister decided to come in. Anyway, so yeah, so this is already a negative, so we can just do this, add the negative version of this, or in other words, if you imagine this as a distance, so it's positive 25, you do this larger distance, take away this smaller one, so it's 402,250 take away 25, which is just 402,225 meters, and then in kilometers, that's just 402.225 kilometers for your answer. Fully rationalize this, you can write this as 2 over x to the power of a third. When we're rationalizing, what we're actually doing is we're taking away the radical sign from the bottom, from the denominator. So how do we turn this radical into just, you know, not a radical? One way that you can do it is you multiply it by x to the power of 2 over 3. Because if you multiply by x to the power of 2 over 3, 2 over 3 plus 1 over 3 is just 3 over 3, which is just 1. So if we multiply the top and bottom by x to the power of 2 over 3, you'll have just x on the bottom, and you'll have 2x to the power of 2 over 3 on the top. That's the same thing as saying the cube root of x squared. So that's your answer. Solve this. Just be a little careful here. If x was a negative number and you multiplied by x on both sides, then this inequality sign would flip. Because whenever you've got an inequality and you multiply by a negative number of both sides, this sign always flips direction. Right, so if it's facing this direction, it goes the other one. If it's facing the other direction, it goes this way. Okay, so what we can do is we can multiply by x squared on both sides, because x squared will always be positive, so we don't have to worry about that. So you get this, and then add x cubed to both sides, add 21x to both sides to get this, and just factorize out x to get that. You can factorize this to get x minus 3 and then x plus 7, so you have this. critical points at x equals 0, x equals 3, x equals minus 7. Okay, this is actually a quadratic. Sorry, it's not a quadratic. This is actually a cubic. Okay, it's not a quadratic. So if you imagine, you just sketch it. This is just a random this is just a random cubic. It's not even this one. All right, but if you just draw a random cubic, you know it has solutions at 3, 0, minus 7. So minus 7 there, 0 there, and then 3 there. We want to be greater than 0. So one way that we can do that is by being larger than 3. So x is larger than 3, or x is between minus 7 and 0. Okay, so that's your solution. That's your answer. Using a vector method, prove that the diagonals of a rhombus bisect each other. You may use a diagram to help you. Okay, yeah, so just draw a rhombus, it doesn't matter. And if you imagine this bottom component being, you can just call it whatever you want, but if you imagine this bottom one being A, and then this one here being B, and then just draw in the diagonals to get this, we want to prove that this is a half of this full distance, or this is a half of the full distance, or any one for the other sides. Let's just label it, so we can call this A, B, C, D, and then we'll call the middle X. It doesn't matter what you call it, obviously, just as long as you're referencing them correctly. So you got this. We want to find what AX is. We can't do that straight away, but what we can do is we can find AC and then call AX some amount of AC. So AC is going to be B plus A. AD is the same as BC because it's a rhombus, so this is B plus A or A plus B. And then we want AX. We can call AX some amount of it. If you imagine K as some decimal number or some fraction of this full line will get us this smaller line here. We'll call that K. We don't know what it is, we'll solve for it later. Just expand this, you'll get that. We're going to do the exact same thing, but you know, go in a different way. We can go from B to X to find what B to X is. We can't find B to X straight away, so what we can do is we can say that, oh no, sorry, never mind. We can just find another way from A to X. Not this same way that we just did, just a different way. We could go this way and then down this way. Okay, so how do we find out A to X? Well, we could go B up here and then BX. Okay, so we'll do it that way. How do we find BX? Well, we need to find BD. BD is minus B plus A, or A minus B. Okay, and now we need some fraction of it. We'll call that fraction lambda. Lambda is just some variable. It's a fraction of this full line BD. Okay, so we'll call it lambda A minus B, and that will give us BX. Okay, now we can just plug this back into there and expand this, obviously, first. To get that, we know that AX equals that, also equals that, so set it equal to each other. Now we're going to equate coefficients. So what that means is just looking at the coefficients for each variable, for each vector. So if you look at the A's, so what's around the A basically, you've got a lambda here and you've got a K here. So we're saying that lambda equals K. Now we're looking at the B's. We have 1 minus lambda equals K. We know that lambda equals K, so we can say that 1 minus K equals K. So 2K equals 1, or K equals a half. That means lambda also equals a half because they're the exact same. If it's a half, it's going to be half of that full line. Bisector, bi, to cut in half. Therefore, it's proven. A group of 5 numbers are such that the mean is equal to 2, the range is equal to 6. If we just call the total of them x, okay, we can say that the total is 10, 5 times by 2. You might need to think of it as a bit like this. The total over how many there are equals the mean. Okay, just think about that. That's how you calculate the mean. Therefore, the total will obviously be 10. 5 times 2 is 10. Sorry about that. Anyways, yeah, x equals 10. You've got 5 numbers, okay, here. And say if we call the first one n, and if the range is equal to 6, then this last number here must be n plus 6, because the difference is 6. That's the range, it's the difference, okay? We want to find, you know, the largest and smallest value of the median. If you imagine it, is we only have 10 shares to give. Okay, we only have a total of 10 to distribute unevenly across these 5 numbers, then we want to give the most to the median. Okay, now if it's the median, it has to be less than or equal to this number here, but it has to be greater than or equal to this number. We want it to be the largest, so it must equal n plus 6. Okay, but if it equals n plus 6, this must also equal n plus 6. Otherwise, it wouldn't be the median, because, they'd swap places, because it's always from smallest to largest. This one here, we'd actually call this one n, and not n plus 6, because if we only have a total of 10 to give, why would you give more to a number that's insignificant? Because we want this number to be as large as possible. So if we're taking shares from this number here and giving it to this one, then by making this one n plus 6, it's giving us a smaller value for the median. Just think about that for a little bit. You can set this one as to n plus 6 and then, find out what that gives you. And we'll do that later. But anyways, this will give us the largest value for the median. Okay, so sum all of these together. You have 5n plus 18 equals the total, which is 10. So 5n equals minus 8, or n equals minus 8 over 5. Minus 8 over 5 plus 6. Minus 1.6 plus 6 is 4.4, which is the median. And that's the largest value, as we've just discussed. The smallest value is, well, if the median equals just n. Okay, so if that equals n plus 6, then this one equals n. And that means this one must also equal n as well. Okay, because it can't be larger than the median. It can be smaller, but we'll just call it n, okay? Because we don't know. Anyways, yeah, that's the case. So we've got 5n plus 12 equals 10. By doing this, we're taking more shares away from the median and then distributing it elsewhere. We can distribute it over here, because then, this number would be, more to the right, because it can't be greater than the median. So it has to be the smaller than or equal to. So that's why the ones before are n. Okay, and this one can't be n plus 7 or n plus 8 to give it a larger share, therefore giving n a smaller share, because it has to be smaller than this one here, and this one has to be at most at least n plus 6. Okay, I hope that makes sense. And as you get 5n plus 12 equals 10, so 5n equals minus 2, n equals minus 2 over 5. And that's the median, and that's the smallest value for it. Solve this. Okay, so we need to remember one thing for this question is, we've transformed it, so we've squished it in by 3, okay, and then we've moved it 60 degrees to the right. Okay, if you inverse both sides, you get 3x plus 60 equals 30 degrees. The other solution will be 180 minus 30, so 3x plus 60 equals 150 degrees. But what I'm also going to do is I'm going to add on the the period of the wave, so it repeats every 360 degrees, because that's just what sine does. Okay. This K here, what this represents is what cycle the wave is in, or how many full cycles it's taken. So if it repeats once, it just goes like this and finishes at 360. If it repeats twice, it goes up, down, and then up. So that's done once. So k equals 1 there, and then another time, so k equals 2. And so, that's what this represents. If k equals 0, it's not it's not looped. Okay. Oh, sorry, k equals 0 and then k equals 1. Just think about this. This is how many times the the loop has restarted for sine. Okay, the reason why I've done it now is because if we're squishing it in by 3, then we can just first of all take away 60 from both sides on this one, and then now we can divide by 3 to get this, and now we can see that it's actually repeating every 120 degrees now, not every 360. Otherwise, we wouldn't have considered that it needs to be repeated every 120, maybe. So that's why I've done this. You'll get this. Just think about this. You can write any question like this in this form to get the right answer, and it's just much quicker, much better. You'll get this. K is a positive integer number. Sorry, not positive. It can be negative, because you could just repeat in the negative direction. But obviously, we want to be greater than 0, so it will be positive. K equals 1. Let's see where it is after it repeats once. That's 110 degrees. Repeats twice, it'll be 230 degrees. Repeats 3 times, it'll be at 350 degrees. If it repeats 4 times, well, 120 times by 4 is 480. Take away 10 is 470. Don't know why that took me so long. 470 degrees is not in the range. And if we plug in k equals 0, which, we can, but the problem is we'll get a negative solution, and we don't want negative solutions. Okay, so that's the first part done. The next part, take away 60 degrees from both sides. Same thing. And then we'll divide by 3 to get this. Let k just vary. So you can actually have k equals 0, and we'll get to that later. But when k equals 1, you'll get 150. When k equals 2, you'll get 270. When k equals 3, you'll have 3 multiplied by 120, which is 360. 360 plus 30 is 390 degrees. That's out of the range, so we don't want it when k equals 3. K equals 0 works because you still get a positive number that's within the range. So k equals 0 works. So it repeats at 0, 1, and 2, and 3 for this one here. Okay, so your solutions are 30, 270, 150, 350, 230, and 110. Okay, just, I think the hardest thing to see about this question is this here. Like, this part is actually quite difficult to spot. Just think on it for a little while, and hopefully it'll come to you. Next question, question 19. A student solves a quadratic equation in the following way. It's in the form x squared plus bx plus c. That means a equals 1. Okay, and he says that minus 2 alpha equals b, and alpha squared minus beta equals c. So we're saying minus 2 alpha equals this here, alpha squared minus beta equals that. And it says that all solutions are in the form alpha plus or minus root beta. Okay, well, how could he have derived this? For any question, linked to the quadratic formula, and you've been given basically no numbers, just try anything. This is a 5-mark question. It's a very difficult question. Just try anything. How can you have solved this? Well, let's plug this into the quadratic formula and see what we get. This is the quadratic formula. You should know this. A equals 1, so just plug that in. You'll have this. Okay, now how has he gotten this and that? So we're saying that solutions are alpha plus or minus root beta. So this is somehow equal to alpha plus or minus root beta. Well, where's he gotten alpha? Where's he gotten beta? Let's just try stuff. Okay, let's maybe split these two fractions up to get this. Minus b over 2. Okay, this looks promising. Okay, and this square root and this 2 here looks promising as well. What if we bring it down to get all of this over 4 and include that within the square root? It's the same thing. We've not changed it at all. Okay, now it's quite clear to see, well, alpha equals this here, right? And then that means beta must equal this here. But does it? Because we still need it to meet this condition here. So we're going to hold off on this for now. But we can say that alpha equals this. This is fine. It doesn't disturb this condition here. So if we say that, we can say that alpha equals this first of all. I've not done that yet for some reason, but I've just split these two up. I'll come to that in just a second. But if you notice here as well, well, if you square alpha here, which we've called alpha here, you'll get b squared over 4. So alpha squared will give you this. And we want alpha squared minus something that looks like minus beta. So that means 4c over 4 could be beta. Or, first of all, let's just simplify it to get just c here. Okay, and we know that alpha equals minus b over 2. Okay, and then this would just be alpha squared, as we've just discussed. So root alpha squared minus c equals root beta. Okay, so what can we do with this? Well, we can just equate coefficients. So we can set this equal to that. Well, it's actually not equating coefficients. We're just equating it based off the fact that they're both radicals, so we know that they are somehow related. But if we equate this and that, because they're both equal to x, and we look at just the radical, you'll see that root alpha squared minus c equals root beta. So you'll have that, and you square both sides to get alpha squared minus c equals beta. Bring beta to this side, bring c to that side, you have alpha squared minus beta equals c. We said that alpha equals minus b over 2, so how do we get this? Really simple, you just multiply by minus 2 on both sides to get b equals minus 2 alpha, and that's your answer. Solve these simultaneous equations. Okay, multiply by 4xy on both sides, and then simplify this down. We'll get 13 equals 2xy. What you could do is you could rearrange for x or rearrange for y and then plug it into there. But the problem with that is when you do that, you'll actually have a quartic. Now, a quartic is not in your spec. But to be fair, neither was that 1 marker. But anyways, a quartic is not in the spec, and it's just really difficult to solve. So that'd be a terrible question to give. So is there another way that we can approach this question to solve it? Well, yes, because if we leave it like this, okay, and we've got x squared plus y squared equals 36, what if we add 2xy to both sides? To get this and that, okay? We know that 2xy equals 13, so we'll make this equal to 13, and then we'll sum these two together to get 49. And now you'll notice that this is actually a perfect square. It's x plus y all squared. Okay, now it's much easier just to square root both sides to get x plus y equals plus or minus 7. This is much more simpler, okay, than if you were just to have plugged it in and gotten the quartic, which is x to the 4 or y to the 4. So this, where can we go from this? Let's just consider what, x plus y equals 7. We'll think about the negative one later, but just imagine x plus y equals 7. Here, let's now rearrange for either x or y. I'll pick y. Okay, and now we can plug this into there, because this is much easier to solve. Plug this into there to get that. Multiply by 2x on both sides to get this. Take away 14x to get this quadratic. And this quadratic, you can't actually factorize it, unfortunately. It was quite hard to write this question with nice numbers. But yeah, what we're going to need to do is either complete the square or put it in the formula. I chose to complete the square. I'm sure you know how to complete the square. We did it on the first question. You do this, and then this is x minus 7 over 2 all squared minus 49 over 4. Distribute the 2 to get this, and then this is 26, so 49 take minus 49, add 26, so that's minus 23 over 2. Add 23 over 2 to both sides to get that. Divide by 2 to get 23 over 4. Square root both sides to get this, and then add the 7 over 2 to get that. Root 4 is just 2, obviously. So you have this, and then just bring them together to get that. And I'm sure you knew how to do that, hopefully. But anyways, we've got the two solutions for x. We have the positive solution, and then we have the negative solution. Rearrange this for y, so we have y equals 7 minus x. And then just plug in, first of all, the positive solution. You could pick the negative one first, doesn't matter. Plug it in. This is going to be a minus 7, and then a minus root 23. This is 14 over 2 minus 7, so this is still going to be the same. It's still going to be 7, and then it's going to be minus root 23 over 2. You know, just think on that if you need to. Now we'll do the same thing, but we'll plug in the negative solution. So you'll have this. This will become a minus 7, and then a positive root 23. So it's the same as this, but this is a positive. So you've got that. Okay. Sorry for that, I accidentally gave spoilers for 2 of the solutions for y. Anyways, so we've got this as these are the solutions. So the positive x will give you the negative version of the y, and then the negative x will give you the positive version of the y. Okay, and so we've already used x plus y equals positive 7. Now let's use x plus y equals negative 7. Okay, and we've still got 13 over 2x equals y. You know, you could rearrange for x either, doesn't matter. Plug this into there. If you notice, this is the exact same as the other one, but we're going to have a positive 14x instead of a minus. And when we complete the square, you can just instantly do it, because it's the exact same as the other one, but instead of it being minus here, it's a positive. Okay, so the solutions, you can just straight away tell it'll just be this, but it's going to be in the negative 7. So you'll have this. You could just go the long way and just do it normally, but you might be able to see this is much quicker. So you have this as the two solutions for x. Plug it into here. This is going to be y equals minus 7 minus x. Plug in the positive x first. You'll have this. Just work through this. You'll get minus 7 minus root 23 over 2. And then when you plug in the minus version, you'll have minus 7 plus root 23 over 2. So the positive solution here corresponds with this one. Negative solution here corresponds with this one. So this gives you that, and that gives you that, and that's all 4 solutions. A football tournament with X number of players, with X number of teams is played. Team A has a 30% chance of winning each game they play, and they play every other team exactly once. What is the probability that they win the entire tournament, given that they must win each game to move to the next round in terms of X. Okay, well, if there was 16 teams, then each team would play every other team, excluding themselves. So they'd play it 16 times by 15 total games. Okay, and if you imagine that just in terms of X, so we have X multiplied by X minus 1, except it's not, it's actually divided by 2, because think about it, if Team A plays against Team B, that's the same as Team B playing against Team A. So we have to half it, because there will be repeats, because we're looking at combinations, not permutations. You don't really need to, worry about that. Anyways, so you'll get this. You've got a 30% chance of winning. A 30% chance of winning is just 3 over 10. Okay, I'm sure you knew that. And if you think about it this way, if you had a tree, okay, and each branch was a probability of 3 over 10, and you need to win this many number of games, okay, so say there was 2 games, and there was a 3 over 10 chance of winning one of them. It's 3 over 10 multiplied by 3 over 10. If there are 3 games, it'd be 3 over 10 multiplied by 3 over 10 multiplied by 3 over 10. But here it's x multiplied by x minus 1 over 2 lots of games. So instead of it being 3 over 10 to the power of 2 for when there was 2 games, or to the power of 3 when there's 3 games, or to the power of 5 when there's 5 games, it's to the power of this when there's this number of games. Okay, so the answer is the probability to the power of the number of games, which is this. You can expand this, which is x squared minus x, and that is it. That's the entire paper done. Hopefully I've gotten everything right. I hope I didn't mess something up by accident. You can check and comment if I've put something wrong. Anyways, that's it. Thank you for watching.